Good morning, viewer. Biendas here. Here's the most amazing news for our viewers. Animal behavior. Animal behavior is known to rely on transforming sensory information into motor commands, often influenced by an animal's internal needs. While in mammals and other large animals, this process is supported by complex brain processes. Simpler version of it might also guide the behavior of smaller living organisms, including insects. To plan their actions when sensory cues were not available, some animals have evolved to instead rely on internal representations of their relationship with their surroundings. These representations could include information related to their head direction or collected by place cells. Neurons. Neurons in the hippocampus that form internal maps of environment. Researchers at Howard Hughes Medical Institute recently explored how fruit flies simultaneously map new environments and use these internal representations to learn what goals to pursue. This paper, published in Neurons, offers new insight into how internal representations can guide the goal directed behavior of animals. Anchoring goals to spatial representations enables flexible navigation but is challenging in novel environments when both representations must be accurate simultaneously. Chunto Dan Bradke Holz and their colleagues wrote in their paper, "We propose a framework for how Drosophila uses internal representations of head direction to build goal representation upon selective thermal reinforcement." The researchers conducted experiments on common fruit flies, that is scientific name Drosophila melanogaster. The behavior of the flies was conditioned using heat, which was linked to different instances of repeating visual patterns. These visual patterns altered the fly's internal HD representation, allowing the researchers to observe how the evolution of HD representations interacted with the fly's goals to ultimately shape their behavior. Using machine learning algorithms and data collected during previous studies on fruit flies, the researchers tried to determine how these processes might be carried out within a region of the insect brain known as the central complex. We show that files used stochastically generated fixations and directed saccades to express hidden preferences in an operant visual learning paradigm that HD neurons are required to modify these preferences based on reinforcement, wrote Dan Hulse and their colleagues. We used a symmetric visual setting to expose how flies, HD and goal representations co-evolve and how the reliability of these interacting representations impacts behavior too. Behind this exclusive report.